Hi, my name is Lisbeth and today we're going to be going over chemical nomenclature. In other words, we're just going to learn how to name chemical compounds. So before we start naming, we have to understand that there are two different kinds of molecules or compounds. So the first kind is an ionic compound. An ionic compound contains a metal and a nonmetal. And there are two kinds of ionic compounds. There's some that have a fixed charge and some that have variable charges. Your fixed charge are going to be the ones in the columns 1 and 2, as well as things like aluminum, silver, and zinc. The variable charges are going to come from your transition metals, the ones that you don't know exactly what charge they have. So for your fixed charged compounds, the first molecule or the first element is going to keep its name. What that means is that the same way you would say it, the same way you see it on the periodic table, is the same way you're going to write it when you're writing out its name. The second one, however, is going to have the root of the name, and you're going to end it with the suffix "ide." So a common example that most people know, or most people will recognize, would be NaCl. So if you go onto your periodic table and look up what Na is, it's actually sodium. So as we said, the first one keeps its name, so we're just going to go ahead and write it. And the second one is going to have its root and then "ide" after it. So the root of chlorine is chlor, and then we're going to add "ide" to it. So that is how you name a fixed ionic compound, or an ionic compound with a fixed charge. So then now we're going to move on to variable charges. This one's a little bit more complicated because we don't know what the charge is. So the first one still keeps its name. You're going to see that this is going to be a common element throughout all of the examples we're going to do today. And then the second one is going to have root and "ide" as well. The only difference is that here we're going to use a Roman numeral to indicate the charge of our metal. So this is the part that gets a little tricky. So let's do an example. Whoops. And my example is going to be PbCl2. When you look onto your periodic table, you'll see that Pb is lead, so we're going to go ahead and write that. And we're going to see that chlorine is going to, well, Cl is chlorine, right? So chloride, just like we did over here. However, we need to indicate the charge of Pb, and that is because if someone's doing an experiment and they use a different kind of charged element, that could be bad news. So I'm going to do the math to find what the charge of Pb is in this corner over here. So we have PbCl2, and we're trying to find the charge of Pb, so we're going to make that X. But don't be scared, it's very easy math. Okay? So we know that the charge of chlorine has a fixed charge of -1 because it is a halogen. It is in group 7. So -1, and there's 2 of them, so we're just going to multiply that by 2. And there is a neutral charge here, there's no charge here, so it's going to be equal to 0. If there was a charge there, then you would just set this equation equal to whatever charge that is. So let's say this has a -1, then you would set it equal to -1. But that's not the case here. So now we're just going to solve for x. So x, this is -2, is equal to 0. So now we can just say x, we add 2 on both sides. So x is equal to +2. That means now this will change the name to lead 2 chloride. And that's basically how you write the variable ionic compounds. So now the last thing we're going to do is go over covalence. A covalent molecule is two nonmetals bonded together. And the difference between an ionic and a covalent compound is that an ionic compound will transfer electrons. These share electrons. So like I said, we have a common trend. The first one is going to keep its name still. And the second one is also going to have, you guessed it, root with an "ide" at the end. The difference is that here we're going to use Greek prefixes to indicate how many there are in the molecule. So how does that look like? We're going to do an example of one that's also very common. Right, so C, when you look on your periodic table, is carbon, so he keeps its name. And then here we have oxygen, so that would be oxide because of the "ide" part. Now, well, you have to memorize your Greek prefixes here, but the Greek prefix for 2 is di, so we're just going to add di in the front. And that's how you name covalent molecules. And yeah, so there you go. Come back next time.